and welcome to this course, Learn NoSQL Databases, the complete MongoDB Bootcamp 2019. So, we will start off by learning about what is NoSQL, then we will move on to what data types is available within NoSQL, and then we will be installing a MongoDB where we'll be doing a lot of practical exercises throughout this course. So, in this course you will be learning all the basic principles about NoSQL, and we will be doing so with the use of MongoDB, which is a NoSQL database. So, first of all, what is NoSQL? A lot of people think that NoSQL stands for No SQL, meaning that no standard query language, but it actually stands for not only SQL. And NoSQL really covers any database that is not a traditional relational database. And NoSQL enables you to store your data in a much more fitting way, because you have a lot of freedom in NoSQL, where in relational databases you rely on this table column row structure, whereas you are totally free of this in a NoSQL database. And the reason why we are using MongoDB in this course is simply because it is open source, it is one of the most popular NoSQL, and there is a large community behind it, meaning that when you are done with this course and you need to develop things on your own, you can quickly search for advice and find answers for your questions just by Googling, because MongoDB have such a large community which has probably already solved the problems that you might have later on. So, when you're choosing between a relational database management system or NoSQL, or maybe both, there are some questions that you might ask yourself. So the questions is listed right here. So you could ask yourself, what does my data look like? How is the current data stored? Is it already stored in a relational database? Or is it already in NoSQL? Because if it is already stored in a relational database, you need to figure out if is it worth the time of transition to a NoSQL database. And then you may ask yourself, how important is the guaranteed accuracy of the database transactions, and how important is the speed of the database. And maybe you should simply split your data up such that you have the best of both worlds, meaning that you will have some of your data in a relational structure and some of the other data like comments and blog posts and so on in a NoSQL, which is much more fitting for such type of data. So, MongoDB highlighted. So, NoSQL is based on a document store model, meaning that you will have documents instead of tables. So we will not be storing our data like you might see in a relational database in tables with rows and columns, but we will be based on a much more document-like approach. And the data that we are storing is either in binary JSON or BSON. And some of you might already be familiar with JSON because it's a very popular structure, and it is used a lot within APIs and JavaScript. So if you don't know what JSON look like, don't worry, you will be seeing such structure in the next lecture. And besides that, MongoDB have also very high performance, and it is highly scalability. And you are just free of SQL injections, meaning that some of the downside with relational databases such as MySQL is that you can inject SQL commands in your queries and manipulate with the data when you are having a live running system, which is not possible using a NoSQL database. So this was a quick overview of some of the highlights and basic terms regarding to NoSQL and MongoDB. And now let's head on to the next lecture. So MongoDB is a document-oriented database. And what document database or oriented database means, it is that we can store all our data relating to a single entity within a document. So this was what I spoke about in the first lecture, the JSON format, what you see right here, where we have all the data within an enclosed collection. So we have the title, and then we have the value of that key, and then we have a version, we have keywords, and as you see right here, we have another object within this main object right here, because that is actually possible in a NoSQL database. So instead of having a relational database where we have different rows containing different data based on columns and maybe be referenced and related to another table containing other information, we will have all the data about an entity within a single document, like we see right here. And it will follow this approach where we have a key and we have a value for that. Similar to when you are programming, you have variables and you have some values for these variables. And when we get into data types in the next lecture, you will see that this is very similar to programming, for example in JavaScript or Java, where we have strings and we have integers and regular expressions and so on. And basically the maximum size of such a document is 16 megabyte, which is quite a lot. So you can actually store a lot of information within such a document. But if you have more than one document, you can group them together, and it is called a collection. So when you have multiple documents stored together, you are having a collection of documents, which is quite similar to a table in a traditional SQL relational database. So now that we know what document-oriented databases are, it's time to look at the data types that is available within the MongoDB, which is our NoSQL database for this course. See you in the next lecture. So, in this lecture we will touch upon the Mongo data types, which is available within the MongoDB. As mentioned in the last lecture, many of the types that you see in the MongoDB is similar to if you have tried programming before, such as Java, C#, or any type-oriented programming language. So you will definitely see some similarities and some well-known types right here, such as string, double, boolean, date, array, and timestamp, which is basically datetime or local datetime based on programming language you have been playing around with. But if you are all new to programming and databases in general, and you have never seen some of these before, don't worry. You will learn all the things you need within this course, so I will teach you each of them in future lectures, where we will be developing our data model, and we will be touching upon some of these. And when we are developing a data model, there are some questions that we need to ask ourselves, because the type of data that we choose to store do matter, because some data types are efficient for some stuff, where others are efficient for other stuff. And as we see right here in the example, which were displayed in the last lecture as well, we see that we have string values right here, meaning a textual representation, which can be seen with these quotation marks right here, where we have the string, or the text, learn NoSQL databases. But in the version right here, we see no quotation marks, and we see that this has another color, it is yellow. This is because this is an integer, which is another data type, and integers contain whole numbers, whereas the data type double, for example, will contain a decimal value. And the keywords right here is actually several string values. As we see here, we have one value, then we have a comma, we have another value, and then the last one right here. This is because the value we see right here is an array. So when we are developing our data model, we can ask ourselves these questions. What basic objects will my application be using? So if you are making your NoSQL to match your application where you have a lot of text, then it is not smart for you to have, for example, all integers, because, well, you can be stored in binary, but it is much more efficient to store the text directly. And if you have multiple values connected to each other, it might be efficient to have an array, because then you can, in your application, just loop over this array to display the different values. So you could ask yourself, what is the relationship between the different objects? Is it one-to-one, one-to-many, or many-to-many? And how will these objects be accessed? Is it by ID? Is it by the property value? or is it by comparing different parameters? And how often will these objects change? So these are some key questions that you need to ask yourself when you are planning your data model. So now you know some basic types within MongoDB, and we have touched upon a few questions. We are not yet able to answer these questions, but when we get to the lecture about planning our data model, we will be retouching these questions, and we will be answering them based on an example case that we will be building in this this MongoDB NoSQL database course. So I will see you in the next lecture. So now that we know some basic theory about MongoDB and NoSQL in terms of what it stands for, what document oriented is, what data type it contains, and how a document actually looks like in JSON format, it's time for us to install the MongoDB, which, as mentioned previously, will be the one that we use throughout this course to learn NoSQL and how such databases work. So you will go to Google, type MongoDB, take the first link, mongodb.com, enter it, then you go up to products, then under software you choose MongoDB Server, then you pick the version that is matching your operation system. For my case, it already chose the right system. I'm running Windows 46-bit or 64-bit, and I will just take this MSI installer instead of the zip. So you click download and wait for the installation file to download on your computer. Once the download of the installation file has completed, you click it in order to install the MongoDB on your operation system. So basically you just follow the installation, click next. I have already installed mine, so I will just click change and I will say next. And this is a window that you should be seeing when you are installing a fresh installation, and you will just keep this run service as network service user and install MongoDB as a service, and then you can choose here where you want the data directory to be. So you click next, and then you also need to have this enabled. It should be enabled automatically, but if it is not, be sure to click this, because we want to install MongoDB Compass, which is a graphical user interface for the MongoDB, such that we can play around with it in a nice graphical manner instead of using the command line. So we click next, and then you basically just say install. In your case, mine was changed, and I will also have an error. You should not. And we just say like so. Once the installation has completed, which for your case should happen without errors because it is for hopefully the first time you install it, you can go to MongoDB, find the MongoDB Compass community application. You will open it, and then it will load for a few seconds. And as you see here, this is an application which has a graphical user interface compared to the terminal, which we were in need of using if we hadn't installed this MongoDB Compass application. Once it is finished load, you should see a page similar to this, where you can connect to host. It is auto set to localhost and a port. We will not be changing any of these because we are just using localhost for this entire course. So we will just click connect, and it will connect to our local host, meaning the MongoDB server running locally on our machine. And then we will have the database names right here, and we can create new database, or we can go into the admin one. And as you see here, we can create a collection, which you hopefully remember from the last lecture, where when you have multiple documents together, you are having a collection. So from here we will be starting our first step towards mastering the MongoDB and the NoSQL framework. So see you in the next lecture. So if you are seeing this error message when you're trying to connect, MongoDB not running on the provided host and port, it means that you have no active server running on your local host. In order to fix this, we will navigate to the command prompt, and then we will enter the MongoDB server file by saying cd, like so. It is typically placed under your program files, MongoDB server, the version you have, and then the bin. You can also navigate to it manually using this graphical folder directory here, where you see the exact path and you can navigate into it. But we will keep it in the console because we need to see the output of this operation. And if we just run an application from within the folder, if there is an error or so, it will just shut down the terminal right immediately, meaning that we are not able to see what might be wrong. So we will be typing MongoDB, and let's see, we have an error. So as you see right here, our data directory cdata.db was not found. In order to fix this, we just simply go to the C directory, create a new folder, data, and again we create a folder db, like so. Now we can exit this, run the command again, and as you see, we are now ready to go in, click connect, and we are now again connected to our local MongoDB. So we can go into our admin and we are ready to start. So now that we have been set up MongoDB Server and MongoDB Compass, it's time to create our first collection. We will create our first collection and name it courses. Click create collection. As you see right here, we now have course. It has 0 documents and a total document size of 0.0 bytes. So let's enter the courses collection and then click on the insert document to create our first document. So in this first document, we will be making the same document. We had an example right here. So we will be typing title as the first field, and the value of that is learn NoSQL Databases, and it is a string, which we can select right here. And the next one is version, and this is actually not a string, it is an integer. So we'll just take integer 64. It is giving us an error because we have no value yet, so we type 1. The next value is keywords, and that was not a string, but that was an array. So in index 1, oh, I misspelled here, keywords. So at index 1, meaning the first element of the array, we had MongoDB. At index 2, we had DB. At index at index 2, which is the third value, we had Udemy, like so. So we click plus right here. Oh, we don't want that one, so we say like so. Add a new field after the array keywords, and that was instructor. And that contained another object, so we will say object, and that object contained the value name, which were Mark, and last name Nielsen. So now we have an exact copy of the example that we saw from previous lectures. So we'll click insert, and now we have our first document, and as you see right here, we have keywords, which is an array, so we can expand this to see the values in here, and we have the object, which is Mark Nielsen. So this is the document overview. We can also go into the table view, meaning that we will see it in a way that you normally see it in relational databases. And as you see right here, we have some difficulties presenting it in the right way like this, because we actually have arrays and objects instead of main values like strings. But in here it is no problem, and we even have a unique ID for this particular document. So we have now created our first document, and I will see you in the next lecture. So now, based on the last section, you should have two documents within your MongoDB. You have the first one, which we created together, which were the one I used as an example in the very first lectures, which is the object document right here, where we have this tile, we have array and so on, and we have an object within this instructor. Then you got an assignment where you were to create your own document, which you should use 3 different data types. I have an example document right here, even though I only use 2 different data types, an array and basically strings for the rest. But at least you should have 2 documents. So in this section of the course, we will be looking into aggregations and how we can use that to manipulate our data. The smart thing about aggregation is that we can manipulate our data locally on the server, meaning that instead of just sending all the data to our application, which is typically a web application running on some separate server, we will have the benefit of getting the database to spend the resources on manipulating the data, such that our web server is not getting overloaded with the data manipulation. So a little example of aggregation and how it works within the MongoDB Compass is that you can, if you are not seeing this, click Add Stage, and of course you should be able to see your documents right here, the 2 documents. If you're not seeing all the documents that you have right here, you can simply just click this and it will refresh this frame right here. So a simple aggregation is the match. So now we can write a query and we will say, let me see, I want the website. So we'll just output a document where it has a website element matching squaretechacademy.com, which is, by the way, my site, and I encourage you to check it out for more resources and videos as well. So we type website, and then we say .squaretechacademy.com, and as you see here, we get this document returned because currently that is the only document that is matching the little query we have made here, the match query, where it should have element website matching squaretechacademy.com. So this was a short introduction to why aggregation is beneficial, because we can run it on the MongoDB server instead of our front end. So in the following lectures we will be looking into different queries that we can write in order to manipulate our data, because as you see here, there are a lot of options. We will not be covering all of them, but I will show you some beneficial ones that you might want to use within your own application. So see you in the next lecture. So in this video we'll be learning about the sort aggregation. So we will go down in the one right here, find sort, and then we can sort our documents based on a field ID and a given sort order for that field ID. So we can, for example, say version, and for that particular example I have created a new document, just this basic one with a version of 2, where we have version 1 here, 1, just to illustrate how this works. So we type in the field that we want to search or sort on, which could be any field, and then you type in a value right here. So if you type in 1 as a sort order, and we'll remove the comma because we're only sorting on this one field, so you can basically sort on multiple fields at a time by just separating by a comma. But if we delete the comma, like so, as we see right here, we have now sorted in an ascending order. And as you see here, the first document does not even have the version field in, so this is put at index 0, and then the next document is ascending by 1, meaning that we have version 1, now version is actually present, and then we have the last document, which is the highest value in this sort with the version number of 2. So with a integer of 1, we are sorting in ascending order, whereas if we type -1, we are sorting in descending order, and now the list is turned around, so now we are sorting from the highest number down to the lowest, so version 2 is now the highest, version 1 is in the middle again, and we have the document with no version field present at all at the end. So this is how you sort based on ascending and descending order. And remember, you can sort multiple fields at a time, just separate by a comma and enter the next value. So if we, for example, type title as our field, we will say title, and let's say 1 there as well. Then you see here that since we are again sorting in ascending order, we are seeing that this document, which does not have a title and no version number, is put in the start, because we are going from the low value to the high value, and then since both of these have title available and this title is longer than this one, we are still also sorting on version number, so the version here is higher, meaning that it is getting overruled because this is the first value. So this is how you can sort based on fields and ascending and descending order. See you in the next lecture. So in this next example, I have created these 4 documents, which is very basic documents. So we have a name and an amount, and we should be able to now to fetch result based on the amount that each of these fictive persons have on their bank account. So we go in, we update this, and as you see right here, we will be using the match, and instead of the version, since that is now not available, probably I will just reset this such that you see once you click match. This is also one of the nice things about MongoDB Compass, and the reason why I'm not going over all of these operators, because when you click an operator, you will get a description of what this operator is for and a basic query for how you should fill the values out so that you can use the operator. So for max, for example, we can say in the query we want to base it on amount, so we simply say amount, and then we say I want to see all of the persons in my database that has more than $400 on their account. So I will be typing $sign right here, and that is not because we are looking for amount in dollar, but you just need $signs when working with operators and so on. And then you say gt greater than, and then I say 400, and we close this off, and now I get returned that Lars and Amanda has more than 400 on their account. So if I then type lt less than, I should not be able to see Lars and Amanda, because now I'm seeing the people that have less than $400 on their account. So this is how you use the match operator, and again you can have multiple search parameters within. You are just separating by comma, which we learned in the last lecture, and then I will see you in the next lecture. So in this lecture we will see how we can subtract amounts from our users and display it. So we are not actually subtracting from the direct value that is stored in the database, but the value that is returned to us is getting subtracted such that we can see do they have money to, for example, enter a movie feeder. So we will go into aggregation, type add stage, and then we will select, let me see where it is, project. So this will be for all our documents. So project is currently applied to all documents since we haven't specified otherwise. So what we want is to return each of our fictive persons with the amount that they have left if they, for example, use $20 to enter to see a movie. So we will type left, which is a new field that will be returned because left is currently not on any of these. So we'll say left, and then we will say there it is. Say sum, and then we say, oops, like so. So we say sum, and we need this, and then we say we want the sum from the amount field, which is present on all of them, and then we say comma, and then we say minus 20. Oh, I forgot to close this off, like so. And so we are getting a new field called left returned, where we can see whether the amount that they have on their account is going to a minus if they pay $20 to enter to see this movie. So if we are using this in our web application and we are returning and is returned with a minus value, then we know that this person should not be allowed to buy the ticket because he simply can't afford it. So we have not yet charged them with this amount because their original value is still stored in their bank account, but we are just doing a check right here to see if they can afford it. So this was the project operator, which can be applied, which is applied to all the documents, and you are able to add new fields in the return string, or you are able to change the name of some of them and do a lot of different operations on them. So in this lecture where we'll see the group operator, I have created 2 new documents since the last lecture. I have created another one with the name of Peter and $100 in the amount, and I have created another with Lars, and he has an amount as well. So in this example you should see all these as bank records where people are depositing cash into their bank account. So we can see that the first one has deposited 200, then Peter comes with 150, Lars with 500, and so on, and then again Peter deposits another 100, and Lars comes again. So now we want to make a summation about the total amount that our 4 fake citizens here have on their bank account. So we go into aggregation, remember to refresh such that you have all the documents right here. So we only want to get 4 documents returned with a summation of their total amount. So what we will do is go into this find group, and then in the first one right here for the ID we will type the field of their name, because we will use the name as the ID such that documents with similar name ID will be seen as equals. And then we will take the field right here, and then we will say total amount, because that is the new field value we want to return, their total amount based on all their deposits. And then we want the sum operator, so we say sum, and then we want the amount because it is the amount that we want the summation of. So we type the amount right here, and then we'll remove this pointing arrow, like so. We will see that we have 4 documents returned based on this operator, and we see that Lars has a total amount of 530, and let's see if that match. First he deposited 500, and then another 30 right there, and Peter has deposited 100 and 150, so a total of 250. So now we have used the group operator to sum up the amount that our 4 citizens here has deposited over the entire lifespan of the database, which is of course a very limited lifetime. But this was the group operator. See you in the next lecture. So now that we have played around in the MongoDB Compass graphical user interface right here, it's time for us to move into the MongoDB shell, where it is easier for us to create MongoDB scripts and manipulate and use our database. So in order to do so, we need a IDE, and we'll be using Atom for this course, so you can navigate it to using this web page right here. It is an open source code IDE, so you should be able to download it for free. All you have to do is enter the site, click download. Once the file has been saved, open it and install it. So once the file has been downloaded, double click and open it. Once the installation has completed, Atom should start up and you should see a similar interface like this. Once that is done, you're ready to move on to the next lecture. So now that we have Atom installed, it's time to see how we can access the MongoDB shell. In order to do so, you will open the command prompt, type cd, navigate to the installation folder just like we have done before, but whereas you before clicked Mongo and a D to get the MongoDB service up and running so that we can connect to it using MongoDB Compass, you will now just type Mongo without the D. And we are actually now within the MongoDB shell, and we can execute command from within here and actually control our entire database and service from this terminal. So this is the terminal shell that we are going to use later in this lecture when we start to write scripts in here. Then we will write the scripts in the text editor and execute them within the Mongo shell. So for example, you can see the database that you have currently in your MongoDB service. Just an example, you can type show DBs and you should see the same 3 databases as you did in the MongoDB Compass. So this is how to access the MongoDB shell. I'll see you in the next lecture. So now that we have learned how we can use the MongoDB shell and we have the Atom IDE installed, we will be starting writing our first scripts to be inserted into our database. So I will just make this a bit more suitable for what we're going to do, like so. So the first thing that we are going to do is to create a new file. You can simply just click new file, like so, new file, and then you simply just save it, and then you save it as, you can just save it here, so we'll call this MongoDB script.js for JavaScript. Okay, so we just save it in the desktop, it doesn't matter, like so. Okay, so we are going to insert some documents into our row. So what we're going to do is type db.students, and this is to be the collection that we want to insert into. So if we go into the Mongo Compass, remember that a collection was, for example, the courses, which we have used in the last lectures. But now we want to make a new collection named students, and since we don't have it yet, MongoDB will automatically create it just when we write it out, followed by the DB. So then we say that we want to insert many, and we want to have an array of documents. So we say name for our students, so we say name, and if it should be Mark. the reason why we saved it in JavaScript is to get some colors and stuff on, so that we can see the difference between what we are writing instead of just all gray text. So we'll say age, and then we'll have a field called enrolled class, which is math, and then a comma to indicate that we have a new document as well. So we'll just copy this a few times. Then we change the name to something new, so that we can see that we have our different students. And their age as well should be different, just to get an indication of how this works. And then some of them should be enrolled in computer science class, whereas the rest is enrolled in the math class. So we just copy this, then we go down here to our MongoDB shell, and then we say use admin, and now we have switched to DB admin. So by inserting this, got to capitalize the M, then we will copy it again and right click in the cell, type enter, and acknowledge true, inserts ID, meaning that this is the ID that each of our documents has received, because it has a unique ID. And you will see that it is similar right up to the end, where it has 2, 3, 4, 5, 6. And now we can go to our MongoDB Compass, update this, and now we see that we have a new students collection with the students that we just created. So instead of doing it through this graphical user interface, you can write in a text editor the commands that we want to execute and simply just paste it into the MongoDB shell, or you can also write it directly in the MongoDB shell, but I find it more suitable to do it in here in order to manipulate and see if there are any errors before typing it in right here. So now that we have inserted our students, it's time to go a bit further in the MongoDB shell. See you in the next lecture. So now that we have inserted these 5 students, we will try to look up the students who has enrolled in the computer science class. So the way that we're going to do this is again typing DB and then students, because we inserted them in the students collection, and then .find, and here we simply declare what kind of field we are looking for. So we are looking for the enrolled class, and we want to have the ones that is enrolled in computer science. So we will just write computer science, and that is basically it. So by copying this one, going down to the MongoDB shell, right click to paste it, enter, and MongoDB will return the documents that contains an enrolled class field with the value of computer science. So this is a way to look up your different documents based on a given value that you are interested in. And as we saw in the previous lectures with the aggregation, you can also use find and values with greater than and so on. An example of such is to take, for example, the age and then make a lookup based on their age. So we will type enrolled, type age, and then we will say $, greater than, and then we will say 24. So copy this, again put it down, paste, and then we get returned the students, document students who has an age greater than 24. So we have currently 2 of these students, which is Tim and Camilla. So this is how you can use the find operator to look up documents and data in your MongoDB database. So now we want to make an update to the documents that we have. So we will just remove this parameter to see the current documents that we have. This will return all documents, and as you see here, they are exactly as they are now. So now we'll be making an update such that the students who is currently enrolled in the math class will be now enrolled in the computer science class. So the way that we're going to do so is typing db and again the collections students, and then we type update, and within this we will say enrolled class where we have math, and then we say the operator set, and then we want that to be computer science, and then we copy this one right here, paste it down here, and let's see, we have an error. So we forgot two things. We need to do it like this, and then of course we need to say that the parameter, or the field that we're going to set is again the enrolled class, like so. So we copy this, paste it, and let's see if we use the find. We now have that our top user right here, the first one, is now enrolled in computer science because we updated like one, meaning that we updated the first row. So if we want to update all of them, we need to make the following expression. Where we had before math for 3 of them, we now have math for only 2 of them. So in order to update multiple documents, we will add a little field value of true. So we'll say multi, and that should be true. Then we will copy this again, paste it to the MongoDB shell, run this, and we see now n modified is 2 because we had 2 left with math. So if we use the operator db students find, we now see that all of our students is enrolled in the computer science class. And if we go to our MongoDB Compass and we update this, we now see all values is updated to computer science. So now that we have seen how we can insert, find and update our documents within our students collection, it's time to see how we can remove documents as well. Let's say that we have a user that is no longer part of our class and we need to remove him from our database of enrolled students. In order to do so, we will use the remove statement. So what you have to do is type db as we are used to, and then students, to be sure that you're using the right collection, so our students collection, and then as we have done before with find and update, you type remove, and then you specify who you want to remove. In this particular set we have a user named Tim, and I will remove Tim because he is no longer part of the computer science class and is no longer needed to be in our little data set right here. So I will say remove of name, and then we will say Tim, and then I will copy this, right click to get it taken in, and as we see here, by result we have removed one object. So if we take the find statement and use that, we now see that whereas Tim before was part of the set, we are no longer seeing him because we have simply removed that document. And you can also see this if you go to your MongoDB Compass, and as you see, he was part of the dataset, but if we update this, he has now been removed and are no longer part of this collection of documents. So this was how you could remove documents from a collection. See you in the next video. So in this section we will learn how we can use the MongoDB shell to do our aggregation. We have in previous section used the MongoDB Compass to make aggregations using this nice graphical user interface where we had the operators right here and we could choose between them and get some description and in some of them examples of how the statements and expressions should be written for it to work. But you can also do all that in the MongoDB shell. So let's give it a try. We will start again by writing db students because that's our collection, and then we type aggregate, and then we say group because we need the average for all our students right here, the age of our students. So we will say group, and then we say ID, and that should just be equal to null because we just want to return a value expressing the average age of our student. So we will call this new value average age, and then we say it should use the average operator like so, and that it should take the values from the age field right here. So we say age, and if we take this first, let me take this one right here, paste it in. So we are going to take all these numbers, add them up together, and then divide it by 4, or well, the MongoDB is doing that for us with this expression we have just wrote right here. So if we copy this, paste it in, and as you see, we are now getting a document returned with the field average ID, and the average age, of our 4 students can be seen right here. So this is how you can use aggregation within the MongoDB shell. So in this lecture we will learn how we can use the MongoDB shell and the aggregation operators to make an array of values. So we want to make an array with all the names of the students in our collection. The way that we are going to do so is to write a similar statement to the one above that we used to get the average age of all our students. So we'll say db.students.aggregate, then we say it should be grouped, and again we will say the ID of this new document should be null, and we will say students because we will be returning an array of student names, so it's fitting to use students. You can use whatever you want. And then we, instead of the average, then we take the push operator. So we say push, and then we say the name field, which you can see right here. So basically we are referencing to the name field right here, whereas before we were using $age to reference to the age. So it's important that you use the $sign to reference to the value of the field and not just sorry, a string, because if you do not do if you forget the $sign and just write push and then name, you will end up, as we see here, with an array. Oh, did I copy it? Like so. You will end up with an array of 4 names because MongoDB will go in and say, okay, I see that there are 4 students because of the group, and then it just says, okay, you want me to add these elements, and the element that you have chosen is a string instead of a field. So it will just say 4 names, add them to an array, and that is what we get returned. But if we use the $sign to reference to the field and take the value instead, what we will get is an array of 4 elements with all the names of our students. So this is a way that you can use an operator to take values from different documents and return them as an array if you have an application that need to display, for example, a list of the students that you have, and you only want the list to contain the names, and then users can click on the name to see more information. You can use this to filter out irrelevant data such that you're only returning the specific array that you are in need of. So now that we have seen how we can return an array of all our students' name, we will look at how we can make an array with unique values for the entire collection set. So first of all, we will start by getting rid of the old commands right here, so that we have more space. Because in order to test this, we need to add a new field to the student documents. So we will be typing db students, and then we will use the update as we have learned in the previous sections, and then we will simply say, first we need this function like so. Yep. And then what we're going to do is say for for the field name, which is the name value here, we will say that for the name with the value of Mark, which is the first student, then we say set, and then we say city, and that should be a new field, so it will be added on like the age, enroll, class, and name field, and the value for the student Mark in the field city should be New York, like so. So now we just take this, copy it here. So unknown top operator name, so let's see, we forgot to remove this, and then we say modified 1. So now let's try use the nb students.find to see our entire collection and see if this has been added. And as you see right here, we have now this new field of city for the student Mark with New York. So let's say that Thomas is also from New York. We will use this. And he got modified as well. And then let's say that Camilla is from she could be from London. So we need to say Camilla. We update it like so. She got updated as well. And then we have Dean at the last, and he will also be from London. Or maybe he could be from Copenhagen. So that we have 3 different city values. So we will just add this for Dean. And now if we use the db find, we will see that our students have now got this field city added, and we have one from New York, we have 2 from New York, 1 from Copenhagen, and 1 from London. So what we want to do now is to use our aggregation operator to return an array of the unique values, so that we can see how many different cities are our students from. So what we really want is to get an array with New York, Copenhagen, and London, and not as before where we had all the values, because we don't want 2 values returned of New York, because that doesn't tell us anything except that we have more students from New York. So in order to write this expression, we will say db.students.aggregate, and then we will say group as before. So we say group, and the ID of this should just be null, and then we want the student cities. So student cities, like so, because we want an array of the collection of cities that our students are from. And then we say add to set, and we need to do like so. And then we want the city field right here, so we say city. And now we can use this, copy it down here, and as you see, we now have an array of the unique values of the field city. So what the operator is doing is going through all our documents, and when it finds a value that is not yet added to the array, it will add that, but as soon as it comes across a new one like New York, which were already added, it will just skip it and continue. So this is how you get an array of unique values from your collection dataset. So in this section we'll be looking at users and user roles within the MongoDB database server. So far we have been using the admin database, which were automatically created when we installed MongoDB Server on our computer. The special thing about the admin database is that all the users that you create in the admin database has special privileges, meaning that if you, for instance, create a new database and make some users for that particular database, they will only have access and roles within that database, but the users that you create in the admin database will also have roles in your other database, because the admin is like the root database in the MongoDB database system. So when you are logging in as a user to a database, MongoDB will not only search for user credentials in that particular database, but it will also go up and search in the admin database. So you need to be aware of this when you're creating users, and this also means that if you want to create a user that have access to multiple databases, it has to be created in the admin database, because you cannot create a user in another database that have access to multiple databases, because that particular user will only be within that single database. All this will be something that we will learn in this section, so don't worry if it seems complicated. We will start off slow by creating a new database that is not our admin database, and then we will start from there and work our way up. See you in the next lecture. So we'll start off by creating a new database, which we are going to add users to later on. So remember that we have used the use command before when we switched to the database admin, so use admin, and we switched to the DB admin. It is the same command that we are using when creating a new database, because if we type use and then a name that MongoDB is not associating with a database, it will automatically create that database. So if we type use and then new DB, we see that Mongo says switch to DB new DB. It is a silly name, but yeah, you get the point. And if we type DB to see what database we are currently in, we see that we are now in new DB. But if we need to see what databases are on our MongoDB server, we can type show DBs, and what you will notice is that currently our new DB is not present on this list, and you can not see it in the MongoDB Compass as well if you're updating, because the database will first get shown when you start to add something into it, because currently there is no collections, no document, nothing in it. So we'll be inserting a new element. So in this one maybe we will have animals, so we say DB animals. So this will be a collection of documents with elements, so this is the collection name, animals, and then we say insert, and then we make it as a function, or maybe I will just, we will do it up here. So db.animals.insert, and then we have this, and then we will say name of our animals. So the first animal will be a lion, and since this is only to illustrate how databases are created and used and so on, we don't need much more than just the name of this. So we take this, paste it in, And as we see, inserted 1, and if we now type show DBs, we now see that the new DB is present on the list, and if we go update MongoDB, it is also in the list right here. And if we enter it, we see that we have the collection animals, and that collection contains one document with our animal with name lion. So this is how you create a new database. In the next lecture, we will be creating users on this new database. So now that we have our new DB and we have inserted our collection of animals with a document lion, it's time to create our first user. So we will say db dot add user, and remember that you have to be in the new DB, and to check that, just type db, and we are currently in the right database, so we can type db dot add user. Oh, again, I should probably do it up here, then it's much easier. So db dot add user, and then we will say user, and this is the name of that user, so we will say animal user, because this user is going to be able to read from the database, and it is basically a database for animals. So we say, and then the password for this user will just be test, and then the role of that user will basically just be a read role, so we will say read, and that is all we need. We will copy this. So by typing the role read, this user will not be able to write anything to the database. He will only be able to read all the documents that are in the database. So if we type this in, and let's see, oh, it's not add, of course, it's create user. So let's take this, copy it in, and as we see, successfully added user. And if we now type show users, we see that we have this DB is the new DB, the user is animal user, and he has an ID which is saying that in the new DB, and his username, we can see his role and what database he is associated with. So that was how you created a new user. So in the last lecture, we created our animal user account with the role permission of read. But before we can turn off on our authentication for the MongoDB server, we will need to create admin user to the admin database. So what we will do is to switch to admin database. So we'll say use admin and type db, and if we say show users, we see there are currently no users. So what we will do is to use the create users, and we will call this admin, and just password admin. Never do that on a online system. This is on localhost, so it's fine. And then we'll give the role of user admin any database. Then we will copy this, type it in, and now we have user admin. And if you show type users, we see that we have admin user in the admin database, and we are not sharing our animal user because we are currently not in that database. So if we type use animals, oh, it was use new DB, and we say show users, we now see the user for that database. So now it's time to turn on authentication in our data. So what we have to do is type the following command. So MongoDB, and then we say db path, and then we need to specify where we have our data. In my case, it's on the local disk, so I'll just copy this. And then we need to say auth for the authentication. So I will copy this, and then we will go into the command prompt right here. Oh, we will not do that. We will start a new command prompt. Then we will close the current session we have, mean that we will lose the connection to the database. So we will close this, and then we simply go to the folder of our Mongo, which was this one. Remember, in your bin directory of the MongoDB server, you have the MongoD and the Mongo for the MongoDB shell. So type cd and into the bin. And now that we are in that directory, we can just copy it down here. We can copy this line right here. Oh, I forgot that isn't path, it's it patch, like so. So currently the connection is now up again, and we should be able to log in. So a fresh command prompt, we will say Mongo, and then the database that we are trying to connect to, new DB, and then we will say user, and it is animal user. The password is test, and the authentication database is also new DB. Then we type enter, and now we have connected to the MongoDB. And if we type show DB, we are only seeing this single database because our user does not have the privilege to see any other databases. And since we only gave it a read, write, if we try to take this DB animal, type it in, we will see an error because, as you see here, codename unauthorized. So we do not have access to insert anything into this database. We are only allowed to read. So if you type db.animals.find, we can easily read because that is the authorization that we have been given as this user. So this is how you log in with a new user. So now that we have seen how to log into our read user for the new DB, we want to see how we can log into our admin user and then create a new write user which has the right access to our database. So we start by navigating to where we have placed the MongoDB server, and then we type Mongo because we want to open a Mongo shell with authentication to our MongoDB server. And remember that you still have to have the MongoDB server up and running. So Mongo, and we want to connect to new DB. And remember that we created the admin user right here, so that is the one we will be using to log in, because the other user that we have, the test user, only have read access, so it can't be used to create any new user. So we say u and then admin, and the password is again admin, and we want to authenticate to database new DB. Oh, let's see, we have an authentication, and that is because, of course, we first want to use our admin user to log in to admin new DB, like so. And now we are connected, and then we can say show DBs. And then you see right here we have the databases. So we will just switch to new DB, and now we have switched to the new DB database, which is where we have our current test user. So we'll be creating a new user, and we will call this write test, and password will just be test read write access, like so. Then we will copy this, paste it in, and as we see, successfully added user write test with the role read write. So now that we have this new user we are actually able to switch through it and read and write some new data to our database, whereas in the other user we could only read because we got an unauthorized code when we tried to write to the database. So we're going to switch user. So we'll close this session right here, and we still have this up and running. And what we're going to do is to be sure that we have the path here such that it is easy to copy. So we'll go back into the command prompt. Then we will navigate to the directory. Take this down here again. And then we will basically just say again Mongo, and we want to connect to new DB. The user is write test. The password is test, and we want to say our authentication database is new DB, and now we are logged in, and we can check the DBs. So we say show DBs, and as you see, we only see this one new DB because we are this is a local user for that database alone, whereas the admin user were created in the admin database, which means that it has access to all the databases because of the role we defined. So if we take and write db dot animals dot find, we can see that we have the authorization to read, but let's see if we can insert a new animal. So we'll just say monkey, copy this, paste it, and again we see inserted one. So if we execute this again, we are now able to read as well. So now we have a user that is capable of reading and writing to the database. In the next section we will see how we can use Java to create the backend code that is needed for a real application to access our backend database. So see you in the next section. So in this section we'll be looking at how we can take our MongoDB, create a little Java REST API, and call the data from the database into our browser so that we can use it for applications online. So start by going to this website, start.spring.io. Then you see a similar frame like this. All you have to do is just pick a name. We'll just call this Mongo REST. It has to be a Java project, Maven as well, and then you just need to pick a version similar to this or above. This might be a higher version number depending on when you are taking this course. And then what you have to do is take the web package like so, and the MongoDB like so, and then you just click generate project and wait for it to start. Then you need an IDE to code your Java application. I personally use IntelliJ, which you can download a 30-day free trial if you haven't already. It is a really nice IDE, and I will be using this for this small example. You can find it on jetbrains.com under IDE, and you can also use Eclipse, which is an open source free IDE. It is similar to IntelliJ, but have a different layout. So just pick one of them, and then once you have downloaded the file, you are ready to start it up. So once you have downloaded one of the IDEs, in my case IntelliJ, you go to the folder where you downloaded the project file from the Spring start, and my own is right here. So you take this and you extract it just where it is, go back into IntelliJ, click open, then you find the Mongo REST, click OK, and I'll just say new window. And as you see, this has now been set up. If you for some reason do not proper download and set up the dependencies from your POM file right here, then you can simply just right click on POM and under Maven you can say add as Maven project, and it should be set up right. But most likely when you open this project for the first time after unzipping it, it will be done automatically because IntelliJ will detect that this is in fact a Spring application. And if you have not set up your IDE as well, you need to download the Java SDK, which can be done from Java SDK. Then you just pick the link on Google from Oracle, and then you just download the software development kit matching your operation system. Once that is done, you can go back and just select it in your settings. It will pop up, but else you can go to settings. So once the project is set up and you have set the SDK up as well, if it is not downloaded, then you will be able to go to your component right here, Mongo REST, create a new class, and you will say hello Mongo. The name doesn't matter, you can name it whatever you want, but we will be making a little API that we can call from the browser, which allow us to get a string output in the browser. So we will just create and say this is a REST controller, and within this we just need a method, so we will call this public string hello world, and then we will say that this is request mapping, and the method that we are going to use is request method.get, and the part that we are going to use is just hello, and then we will just return hello world like so. And if we go up, and as you see right here, it is already set to run my Mongo application, but if it is not in your case, just click run and select the file right here, and then you can click and it should be able to compile. And let's see, we have an error, MongoDB driver core connection refuse connect. Yeah, so the error that we're getting now is that our Mongo server is not set up, and that is because we have told it to include the MongoDB driver. So we, in order to fix this problem, because our application is trying to connect to a local MongoDB server, in order to fix this, we will just run an instance of that. So go to where we have our Mongo server, this is PC, and there is a user. Oh, not this, we'll just program files, MongoDB server, and then we have it right here. Then we will open command prompt, cd into that as we have done before, and then we simply just run the MongoDB, and it is now up and running. And as we see here, open connection, and we have a successful connection. So we can go to our browser, let's say this one, and then we can say localhost, and we'll be using port 8080 and /hello. And as you see right here, we have a hello world, and that is because we were able to call on localhost on the port 8080, which is the one we are using in our project right here. We were able to call, and since we used the /hello, we just returned this hello world. So now that we have set up the first little get method, it's now time to make the class that will connect to our MongoDB database and return what we have stored in it. now that we have been able to call this hello world from our browser by navigating to our localhost port 8080/hello and seeing that we have this hello world, it's time for us to make the actual connection to the database and tell it what to return to us. So we will be stopping the application. Then we will be creating a new class. We will call that class connector. And in here we will first define some variables. So we say final integer port number, which is the port number, and as you might already know, this is the port number we have right here. So like so. And it is final because this port number is not going to change throughout the execution of this application. So we will say string for the next variables, and we will say authentication user should be equal to write test, and that user should be the same user that you created in your MongoDB with the read write role. So write test. Then the next one will be auth password, and that should be the password of that user, so it is test. Then we will have the host name, and that will be localhost. And then we have the database name, and as you remember, this is new DB, and if you have named your user or the database or the collection otherwise than what I have done, then just put in the right values, because this variable settings right here can be changed accordingly, and this is why the implementation that we are doing right here can be changed and used for any application and any places where you are hosting your MongoDB by just changing these variables right here. So then we say db column name, and that should be animals, because we have the animal from the, I don't have it here, but as you remember in previous lectures, we created the animal collection, which consists of 2 documents. So this last one is going to be encoded password, because we are going to have it encoded. The password we have right here, and that is empty for now, and that is the reason why we are not naming this final, because we are changing this value right here. We could, however, just put this as a single value string, name the other final, but yeah, we'll just keep it like this for now. Then we will create the method, and that is going to return a list of documents, and we'll call this Mongo connector, and we'll be importing this document right here and the list as well. The way I'm getting this auto import up is by clicking Alt and then Enter, and then you will get the choice right here. So then we're going to say try catch block right here. So we say try, and then we say encode should be equal to URL encoder, and that should be encode, and we will have the authorized password, and it should use UTF-8 like so. And let's see, we have an error on handle. Oh yeah, so we currently have an unhandled exception, and that is the one we are trying to catch right here. So we say catch, and then we say unsupported encoding exception, and then we say ex, and then our error right here disappeared. So we just say system.out.println line, so that we can see it if something happened. Normally you will have this in a log class method, so that you can log the error that might occur. And now we're going to define the actual string that will be used to connect to the MongoDB. So we'll say string client URL, and that should be equal to MongoDB, and then we'll be using the variables that we have created. So we will be using the user, then we will have colon, and then we will be using the encoded password, which is now our actual value based on the try catch function right here. Then we will say plus the host name, and again a colon, and then plus the port number, and then slash db name, like so. So this is the actual client URL for connecting to the database with our user and password and the URL domain and what database to connect to. Then we just say Mongo client URI, and then we say equals to new Mongo, and then we say the client URL, which we just created right here. Then we say Mongo client, and then we say Mongo client, and we say equal new Mongo client with the URI like so. And then we say Mongo database, and that should just be database should be equal to Mongo client dot get database, and then we want a database from the DB name right here. Then we say Mongo collection, and we want a document, and then we say collection should be equal to database dot get collection, and then from the column that the collection that we're going to get this from. So the documents of this collection is to be returned, and that is from the animal collection, because we only have that one in this course right now. And then we say list of documents, we call those documents should be equal to collection dot find dot into, and then a new array list, and then closing this off, and then we simply just have a for loop for us to try see it in the console as well. We don't need that, but we will make it just to demonstrate it. So document of the type document in documents, do we have it? Oh, it's not capital, like so. So now we are getting for each document for each type of the type document in the list of documents, we're going to do something, and the thing we're going to do is simply just print these out. So we just say print and then the document, and then at last we will return our documents, which is the entire list. So here we are just looping over the list, printing each document out, but in the method in general we are returning the entire list, because then we can go to our hello Mongo, and instead of this we can say connector, and we want the connector from this one, and then we say equals new connector. Oh, it was the wrong one, as you see right here, so we'll just do like this, and then we will remove this and just say connector equals new. Oh, it was not with capital, that makes sense. I see I forgot to make it capital, so we'll just use connector. And this is a clear error. You should always write classes with capital, because now you can see the difference between these two, and you don't know that this is a class and not a variable. So remember to do that. I will not change it just for this small example, but remember to do it when you're developing your own. And then connector dot Mongo connector, and then we'll simply just make a return statement on this one, and then instead of the string we are returning a list of documents. So with this in the hello world method and this in the connector class, we are now able to run the application once again, And be sure that you have your MongoDB server up and running so that you can connect and read from it. And as we see, it has started up on port 8080, so we can now go refresh this. And as you see here, we are getting a list of 2 elements back. So we have our document with the lion and a document with the monkey. And in here we have the document with the ID name as well. And we also have the ID right here. It is here. So this is how you get your Java application to read from the MongoDB. And as you see, if I go to change this, for example, skip this and make a little change in the password so that it should not be able to authenticate, we will be getting an error because we should not be able to authenticate using a wrong password to our MongoDB. So we will open this up, reconnect, and as you see, we have our type 400, and we are seeing that there is an exception in the authentication because the credentials were wrong. So this is how you can use your MongoDB from without the shell and put it into an actual application. So this little API we have used right here, you can use that in real world applications so that your app or web page can call this REST service in our web server, and then that web server will basically go down to your MongoDB database and return the result. If you want to know more about how you can make such web applications, check out some of my other courses. I, for example, have one where I'm making a recommender system, where I'm making both the front end and back end, so you can see the connection between these two. And then this was all for now. I hope to see you and next time here on Udemy.